One of the biggest problems of working in an office or even worse in a home is the fact that you're going to be in a small confined area where pretty much the air is not properly being circulated. And the biggest problem obviously would be the carbon dioxide. I mean, it would be obviously the best idea to open a window, but sometimes it's not feasible in an office or sometimes if it's really cold outside. So I'm sure you've heard of some of these plants that even NASA did some experimentation on that's supposed to clear up the air for you and to the most part recycle the carbon dioxide for you. One of the more famous ones is called the snake plant. Unfortunately, the biggest problem I've had is I couldn't find in all my research how much plants do you need or how many of them do you need in a specific room in order for you to scrub the carbon dioxide, assuming you have no ability to open a window. So I decided to do this experimentation just to find out what the rate of increase of carbon dioxide is going to be in a specific room size and how many plants or what the size of the plants needs to in order to compensate for the gain of carbon dioxide. Now, obviously, there's a lot of plants that help in clearing up a lot of the VOCs and so on, and some other toxins, but I'm really focusing on the carbon dioxide because you will probably notice once it reaches at least 1,000 parts per million is you start to feel a little bit dizzy, you're going to feel sweaty or hot, and it's going to affect your focus and so on. So here's what I did. So first of all, I needed to make sure that the sensors to monitor the carbon dioxide were accurate, good quality, backed up company, not some Chinese brand that you don't know how accurate or how well calibrated it is. So I found two very good, reasonable priced carbon dioxide monitors. One would be the Temtop, which would be more or less the Rolls Royce of quality when it comes to sensors. And the second one is Netatmo. And they all have their specific features, but I made sure that they are accurate, which you can see they are relatively close in the numbers. And then I wanted to see how to do the proper testing. So first I need to know what the baseline is. So the normal parts per million in carbon dioxide is about between 300 to 400 parts per million. And there's several documentation where you are on the planet, which side, and it changes slightly between season to season, but it's still a good baseline. So this is more or less the parameters that we're going to start with, and you can see toxicity level of where would be the healthy or not. So first of all, I bought one of those hydroponic tents for growing indoor plants, obviously. And it would be a good environment to test this because we can close it up, we can seal up all the air inside to the most part, and see how well it recycles the existing air. And you can get a baseline if it stays the same to the most part, as in the carbon dioxide being fed in is able to be scrubbed out at the same time. We don't want to see it gaining or losing the carbon dioxide to the most part, just so you can have a baseline. You also want to be able to calibrate them just to make sure that they are giving you the same numbers. So from the test initially, what I did is I closed up the tent and I put the plants inside, and I tried obviously with light and without light, the UV lights, just to see if they react differently between day and nighttime, and just to monitor what the reaction is. Is there advantage of when there's light or not light? And you can see from the results that pretty much that the carbon dioxide actually stays relatively the same. It goes a little bit higher as you come in the room and then starts dropping slowly when you get out. And when it's sealed, it stays relatively the same to the most part. Again, you can see now without the plants what the numbers are, and it doesn't seem to be affecting the carbon dioxide that much. So that either tells you that the plants are doing nothing during the day or night, or the results are quite low, as in the amount that is being fed in and going out is keeping it steady. This is without any humans within the tents, so there isn't any additional gain of carbon dioxide. I did this test all around the house as well, just to see what the background carbon dioxide within the house itself, because I wanted to make sure that it's not a matter of leaking carbon dioxide in or out of the tent, and what's the standard inside the house. Obviously outside when I tested it, it was around, let's say, 350 to 400 parts per million. Depends where closer you are to the roads, I guess, or in the streets. But as you can see, these are the numbers. They all stay around between 500 to 550 and goes down a little bit and then goes back up again. And that again seems to be stable around that amount. Now, the next test is I put both sensors inside the office and the size of the office is approximately 7 feet by 12 feet. I was in the room. I closed all doors to make sure there is no leak of carbon dioxide in or out. I made sure the windows are shut. I made sure there's no plants in the office, and I stayed in the office to see what is the amount of carbon dioxide that I am gaining every minute. And as you can see from the graph on both sensors, it's approximately gaining about 13 parts per million every minute. And it doesn't take very long before you reach the uncomfortable stage of 1000 parts per million, where you start to feel a little bit woozy and a little bit tired and sweaty. Now at this stage, I stepped out of the office to make sure it stabilizes, and it stabilizes around between 1300 to 1366 parts per million. So it shows that we are relatively staying around the same amount of carbon dioxide. Nothing is leaking out. All doors shut. I'm no longer in the office, so it's no longer gaining in my carbon dioxide. Then I added both plants on both sides of the sensors. I went outside and shut everything down inside the office again, just to see what is the rate of those two medium-sized plants, snake plants, in scrubbing that carbon dioxide out. And as you can see from here, it's actually quite slow. It's approximately 3 parts per million every minute. And you're gaining at 13, but you're losing at 3. And those are two medium-sized plants. So based on this, what we have learned is that the two plants together, again, they're small, medium-sized plants, is scrubbing about each 1.5 parts per million of carbon dioxide out per minute, which is extremely insignificant compared to how much the office is gaining when you're in the office at that size, which means in order for you to compensate for that carbon dioxide buildup, you actually need somewhere between 8 to 9 of those medium-sized plants, or something 8 to 9 times bigger as a snake plant, for you just to compensate for one person in an office this small. So that's something that, they don't tell you, NASA doesn't tell you, and so on. I'm sure it clears up some toxin if you have in your office, paint and other stuff, but just for the purpose of carbon dioxide, unless you want to turn your office into a jungle, it actually makes more sense to just find a way to open the window every maybe half an hour just to refresh the air. So I hope this video was useful. If you're interested to know on the items that I purchased, in order for you to measure that in your own office, I put the links in the description. Feel free to ping me in the comment section, and I'm more than happy to give you any additional information you may need on the size of the plants, types of plants, or any equipments I have used. Hope that was useful, and see you in the next video.